Welcome to our topic called constrained optimization. So, in production, we know it shows a relationship between two variables. So, our output is in terms of two inputs, which is labor and capital. The reward for labor is a wage, the reward for capital is rent. So a production function is in terms of these outputs. So output is Q, labor, and so it gives us what we call a cost function, which is wages for labor and rent for capital. So we talked about an isoquant. Isoquant looks like this. It has 5 key properties. Number one, what are the properties of isoquants? Properties of isoquants. Who remembers?
They don't crisscross.
Mm-hmm.
That's one.
Mm-hmm. They don't crisscross. That's one. Number two, they are downward sloping. Okay, they are downward sloping. Number three, they are convex to the origin, meaning they obey the law of diminishing marginal rate of technical substitution. So as you substitute one input for the other, the rate at which one input replaces the other will decrease without the other changing. Then they don't intersect, meaning two isoquants cannot cross each other because it would imply that the same combination of inputs will produce different levels of output at the same time, which is illogical. So isoquant says if you're going to produce from here, the same output you're going to have is from here for combinations of labor and capital. So if this is 10Q, this is 20Q, this is 30Q. So it means that at any point A and B to offer the same what? A production output, which is 10. If you're combining maybe uh, 1 unit of capital and 3 units of labor, or you're going to combine 3 units of capital and 2 units of labor, you're all going to produce 10 units. So they're convex, they don't crisscross. You cannot have this one here. It will defy this law because you're going to produce 10 units here and 20 units here. What are you going to produce here? It can't be both. They don't crisscross. The other is that the isoquant on the further right from the origin offer a higher level of production output. So this means that more okay, as you go further away from the origin, you produce more output. Then the axes don't touch each other. This implies that output are produced with one input, either labor or capital, which is not realistic, is in most cases it doesn't touch. So now we go to the principle of constraint of calculus now. So let me take you back to dy dx. So remember we had talked about differentiation. If you're given u is equal to 5x to the power 4. This is du over dx. This is the marginal utility of what? X. You just multiply the numbers and subtract 1 from the power. So what is the derivative? What is the marginal utility of x in this case? 20x3. How do we get the 20x3? We multiplied what? 4 times 5, 20. 4 minus 1, 3. If we have our 6y5, what is du over dy? Du over dy, marginal utility of y. What do we get when we differentiate that? You multiply the numbers, which will be 30y4.
Yes.
But if we have a combination of these two, u is equal to 6 x 6x4 y 5. So this will be du over dx. This is the magnitude of x. So we're going to differentiate with respect to x, leave the y as it is. The y5 will be what? The y5 will be a dummy. So we're differentiating 6x4. What is the derivative of 6x4? 24x3. Then you repeat the same procedure. You differentiate with respect to what? To x, to y, sorry. So du over dy. So now this is our MUY, magnitude of y. We're interested in the y. What is our dummy? We just isolate the x what? The x4 as it is. So what are we going to remain with? 6y5. What is the derivative of 6y5?
Thirty y to the power 4.
We're going to have what? 30y4. Because we've multiplied this and that, so we're going to have 30y4. Okay. So far together.
Yep.
So if we're going to have another derivative, if we're given u is equal to 10x3 and y8. Can you try to differentiate that? Who wants to try MUX and the guys do MUX, the ladies do MUY. So what is the u over the x? Magnitude of x, right? So what is our
So it
dummy?
was y
Y8 is our dummy. So what are we differentiating? 10x3, which is what?
30 to the power 30x to the power 2.
30x2, correct. So let's differentiate du over dy. What do we get? MUY. What is our dummy?
X to the power 2.
X3. So what are we remaining with? 10y8.
Is
10y8, what is the derivative? 80y7. Are we together?
just a minute, Mr. Collins.
Yes.
So when you isolate this guy here, you're going to remain with
Or
the 10 is for both of them, right? So you're going to remain with 10y8. All right. So I need you to acquaint yourself. At this point, you have no option but to think and tell your brain to say, please don't disappoint me. So in this case, you're going to use the y half to both of them because the power. So x half, y half. So when you're differentiating du dx, we're going to have mux. So our dummy here would what? Y half. we're going to remain with what? 2x half. So 2x half, when this half multiplies with that, it is a 1. Then subtract half, 1 minus half, we get negative half. Okay? We do the same. What is du, dy? Muy. What is our dummy for differentiating with y? What is our dummy?
X to the power half.
X half, correct. So what are we differentiating? 2y half. So half times 2 is 1. 1 is invisible. Half minus 1 is minus half on the y. So are you following what is happening here? All right. Let's try if we have 2xy. So let's differentiate with respect to x, the shortcut muy or mux, just to ux there. What is our dummy? It is y. What are we differentiating? 2x. What is the derivative of 2x? It's 2. And we're differentiating with respect to y. What is our dummy? X. What are we going to remain with? 2y. What's the derivative of 2y? It's 2. Suppose we have an even more simpler looking u is equal to yx. Let's differentiate with respect to what? X and with respect to y. So what is our derivative of x? What is our derivative of y? So what's the derivative? With respect to x, what is our dummy? Y. What are we going to remain with? 1x. The derivative of 1x is 1. We'll never write a 1. Differentiate with respect to y, what is our dummy? X. What are we differentiating? 1y. The derivative of 1y is 1, which we don't write. Are we together?
Yes.
All right. So, becoming interesting, right? So now I want you to try to differentiate. Let's differentiate just the derivative. I don't want to go into the nitty-gritties of the equation first. Help me differentiate just um, the function for this. Let's differentiate this together. Q is equal to 10, 100k 0.5 L. So what is dq? dk is the marginal product of what? Of capital. So what is our dummy? L.5, right? What are we differentiating? 100k 0.5. 0.5 is the same as the power half, in short. So what is the derivative of 100k 0.5? 50k negative 0.5. All together?
Yes.
Then you differentiate dq dl. This is a marginal product of what? Labor. So what is our dummy?
K to the power 5.
0.5.
K 0.5 is our dummy. What are you differentiating? 100k, 100L.5. What's the derivative of 100L.5? 50L negative 0.5. All together. Now you're with me. All right. Let's go modify. So suppose you are given 2x, y, power half. And our income was given by 80. And our price of good X was given by 10 kwacha. And the price of good Y was given by 40 kwacha. Then we're asked to use the Lagrangian function to maximize the units of X and Y. So the first step, you're asked to find the budget line. What's the formula for the budget line? Budget line is equal to what? Income is equal to what? Price of good X times X plus price of good Y times Y. So here we have 80 is equal to what? 10x plus 40y. That's all. This is a budget line. Then part 2, to maximize, so I should teach you a shortcut for Lagrangian formula is long. So the shortcut for reducing the Lagrangian formula is MUX over price of X should be equal to MUY over price of Y. This is the Lagrangian shortcut. It will maximize. This is 15 marks. So what is the MUX? So we know U is equal to what? U is equal to what? 2x half, y half. So how do you differentiate derivative of, we already did this one, right? Remember. What is the derivative? What is MUX? Dami here is what? Y half. We're differentiating what? 2x half, which is what? X minus half, right? Yes, Chipo. You have a question, Chipo?
Could you please repeat on the second step?
Which one?
The one after the budget.
So this one here, we're asked to maximize utility, in short, to find the maximum utility. So utility occurs where the indifference curve kisses the budget line. So we're being asked to find how many units of Y and X will maximize utility. So utility measures the satisfaction that is usurped from consuming a unit product by amongst two goods. So in this case, we're assuming we have good Y and good X. All the properties of utility are the same as isoquants. They are convex, they are parallel to each other, they don't crisscross. The utility on the far right offers a higher utility than one on the left. So to calculate the constraint optimization, we use what we call the Lagrangian function, which is utility function with respect to what? That's lambda. I'm sure you've seen something like this. M minus price of X times X minus price of Y times Y. You've seen something like this. This is a Lagrangian multiplier. So most of you get confused when you see this. So the shortcut to this is this. Marginal utility of X over price of X. It should be equal to marginal utility of Y over price of Y. So we now need to find the marginal utility of X. So we're coming from this budget line. When I expand this, this is a question there, which we already did. So marginal utility of X, from here our dummy is Y. We differentiate 2x half is negative half. Then we go to the marginal utility of what? Y. Our dummy is what? X half. And we're differentiating 2y half. So when you multiply that, we're going to get what? 2 times half is 1. Then y, when you subtract half, is negative half. Are we together so far?
Yes.
Right. Then we substitute in here. So x,
Chipo's hand is up.
pardon?
Chipo's hand is up. I don't know if it's a legacy hand or.
I'm sure it's a previous question that she had asked. Chipo, unless there's another question, are you clarified?
I'm okay now.
All right, okay. So now the MUX, we are seeing where it's coming from, and the MUY, we're seeing where it's coming from. So for the MUX, the negative is on the X, the MUY, the negative is on the Y. The price of X is 10, and the price of Y is what? 40. We cross multiply. According to indices, the guy with the negative falls down, so the X will fall down there. So what are we going to have? Half over 10x half. Here is equal to what? X half over what? 40 y half. So when you cross multiply, the half times half according to indices, they make 1. So this will be 10x is equal to what? 40y. Are we together? So when you divide by 10 both sides, our x is equal to what? 4y. This is our first equation we're going to work with. Are we together where we're coming from? This guy goes down, this guy goes down. You can cancel there this, and this will remain with a 4. So y half, x half times x half is x. Y half times 4y half is 4y. So this is where we are here. Are we together so far? Are we together so far? Chipo, are we together? So once you get that, you substitute this back into the original function here. Where there is what? Where there is x, we put what? For y. So we're going to have, here there's x. So we're going to put 4y. So we're going to have 80 is equal to 10x. So here 4y plus 40y. So here we're going to have 80 is equal to what? 40y plus 40y. So what are you going to get? 80 is equal to 80y. So 80 is equal to 80y. So meaning what is our y? Our y is equal to 1. When divide 80 on both sides. Then when you put the y 1 there, our x is equal to what? 4 times 1, which is 4. So meaning how many units will maximize y? 1 unit. How many units of x will maximize utility? 4 units. So this will carry about 15 marks. So this is what I want you to do for question number 5. You come up with a utility function or the production function and substitute. You can use the shortcut formula. You don't necessarily need to use the Lagrangian formula. You can use a shortcut formula to still give you the same answer. Are we together? Okay. So we end here. Thank you so much for the time.